Exercise 1.1, question number 2. Okay, inside first question, let y equal to cos x square plus a square. Now differentiate with respect to x. We will get dy by dx equal to d dx of cos of x square plus a square. Differentiation of cos is minus sine x square plus a square. Now again d dx of differentiation of x square plus a square. This will okay. Here we used formula of d dx of cos x is equal to minus sin x. Now see, minus sin x square plus a square. Again here differentiation of x square is 2x and differentiation of a square is 0 because a square is constant. Okay, therefore dy by dx becomes minus 2x sine x square plus a square. This is the answer. Now second question, let y equal to square root of e raised to 3x plus 2 plus 5. Differentiate with respect to x. dy by dx of d dx of square root of e raised to 3x plus 2 plus 5. So differentiation of square root will become 1 upon 2 square root of e raised to 3x plus 2 plus 5. Again d dx of e raised to 3x plus 2 plus 5. Here we used formula of square root of x. d dx of square root of x is 2 root x. Now next, 1 upon 2 root e raised to 3x plus 2 plus 5. Now see, differentiation of exponential quantity is as it is, e raised to 3, it will remain as it is, e raised to 3x plus 2 will remain as it is, okay, into d dx of 3x plus 2 plus differentiation of 5 is 0. Why? Because see, d dx of e raised to x is e raised to x and d dx of any constant is 0. Okay, now here e raised to 3x plus 2 into differentiation of 3 is 3 into 1 and differentiation of 2 is 0 upon 2 square root of e raised to 3x plus 2 plus 5. Therefore dy by dx will become, this 3 I will take first, e raised 3e raised to 3x plus 2 upon 2 e raised to 3x plus 2 plus 5. This is your answer. This is 3x. Now next question. Third, let y equal to log of tan of x by 2. Differentiate with respect to x. dy by dx equal to d dx of log of tan of x by 2. Differentiation of log of tan of x by 2 is 1 upon x by 2 into d dx of tan of x by 2. Why this is? Because d dx of log x is 1 upon x. Now 1 upon tan x by 2, differentiation of tan x is sec square x by 2, again differentiation of x by 2. So here we used formula d dx of tan x is sec square, that is sec square x. Okay, now see, I can write down this tan as it's a sine x by 2 upon cos x by 2. Similarly, sec square x by 2 will become cos square x by 2, and this 1 by 2 as a constant, and differentiation of x is 1. Here we use some formula like tan x is sine x upon cos x, and sec x is equal to 1 upon cos x. These are the trigonometric functions. Now see, this cos will go for this cross. Here is the cos square x by 2, only cos x by 2 will remain. So this will become 1 upon this 2, I will write down first, 2 sine x by 2 into cos x by 2. Okay, now see, here one formula, it is a really important formula. This is 2 sine theta into cos theta, that will be a sine 2 theta. So it will become sine 2 into x by 2. This is again trigonometric formula, that is 2 sine theta into cos theta is a sine 2 theta. Okay, that's why it become 1 upon 2. Okay, now it will be a sine 1 upon sine x, and last dy by dx 1 upon sine x is a cosec x. This is really simple answer. Here onward you have to use trigonometry. Okay, now for next question, fourth one. Let y equal to square root of tan of square root of x. Therefore, I will write this quite neat. Tan x by 2 differentiate with respect to x. Dy by dx equal to d dx of square root of tan of square root of x. Now this will become 1 upon 2 root tan of square root of x. Okay, here we used, sorry, again here d dx of tan of square root of x. Here we used formula of d dx of square root of x is 1 upon 2 root x. Okay, now next 1 upon 2 root tan square root of x. Differentiation of tan is sec square root x, d dx of again root x. Oh, see, here we used d dx of tan x is sec square x. Okay, now next sec square root x upon 2 root tan root x. Differentiation of root x 1 upon 2 root x. Again we used that formula, d dx of root x is equal to 1 upon 2 root x last. Therefore, dy by dx will become sec square, this will become sec square root x upon 4 root x. I will write down this root x front side, 2 plus 2 into 2 4, again root x into root tan root x. This is your answer. Now for next question. Fifth one. Let y equal to cot cube log of x cube. Differentiate with respect to x. This will become dy by dx equal to d dx of cot x cube, cot cube log of x cube. Okay. Now differentiation of cube is 3 cot square log of x cube, again d dx of, okay, we took differentiation of cube. Now remaining part cot log of x cube. So here we used formula d dx of x raised to n is n x raised to n minus 1. Now next, this will remain as it is, 3 cot square log of x cube. Now differentiation of cot is minus cosec square log of x cube. Again d dx of log of x cube. Okay, here we used formula d dx of cot x is minus cosec square x. Next, this term this minus will come forward, minus 3 cot square log of x cube cosec square log of x cube into differentiation of this will be a 1. Okay, 1 upon, you can write this like 3 log x and 3 by x, or otherwise you can write down like this, 1 upon x cube d dx of x cube. One step will increase. Here we used formula d dx of log x is 1 upon x. Okay, now minus 3 cot square log x cube cosec square log x cube into 1 upon x cube. Differentiation of x cube is 3x square. Now this x square cancels out with this x square, only x will remain. Okay, here we use that formula d dx of x raised to n equal to n x raised to n minus 1. Okay, now your answer, therefore dy by dx is, I write down here only x remains, I will write down that x here, minus 3 by x, oh, sorry, 3 3s are 9, this will become minus 9 by x cot square log of x cube into cosec square log of x cube. This is your answer. Okay, now next one, sixth one. Let y equal to 5 raised to sine cube x plus 3 differentiate with respect to x. So it will become dy by dx equal to d dx of 5 raised to sine cube x plus 3. Now this differentiation of this term is 5 raised to sine cube x plus 3 log 5 d dx of sine cube x plus 3. Here we used formula d dx of a raised to x. Formula for a raised to x is a raised to x log a. So this will become 5 raised to sine cube x plus 3 log 5. Differentiation of sine cube x is 3 sine square x d dx of sine x plus differentiation of 3 is 0. Here we used formula d dx of x raised to n is n x raised to n minus 1. Now this will become 5 sine cube x plus 3 log 5 into 3 sine square x. Differentiation of sine x is cos x. So differentiation of d dx of sine x is equal to cos x. And last we will arrange these terms. Dy by dx is equal to 3 cos x into sine square x into log 5 into 5 raised to sine cube x plus 3. If you don't want to do this step, it's okay. You can stop your answer at this step. Now, next one, sixth one. Seventh one. Let y equal to cosec square root of cos x. Differentiate with respect to x. Dy by dx is equal to d dx of cosec square root of cos x. Now differentiation of cosec x is minus cosec square root of cos x into cot x. Cot of cosec x, square root of cosec x into d dx of square root of cos x. Okay, here we use formula d dx of cosec x equal to minus cosec x into cot x. Now this will become minus cosec square root of cos x into cot square root of cos x into differentiation of square root of 2 cos x will root cos x will become 2 root cos x d dx of cos x. Now see, here we used formula d dx of square root of x is 1 upon 2 root x. Now minus cosec root cos x into cot root cos x into 1 upon 2 root cos x into differentiation of cos x is minus sin x. Therefore, d dx of cos x is equal to minus sin x. And last part is the rearrangement of those terms. Therefore, dy by dx is minus minus will become plus sin x upon 2 root cos x into cosec root cos x into cot root cos x. This is your answer. Okay, this is seventh question. Now for eighth one. Let y equal to log of cos of x cube minus 5. Differentiate with respect to x. dy by dx is equal to d dx of log of cos of x cube minus 5. Now differentiation of this term is 1 upon cos of x cube minus 5 d dx of cos of x cube minus 5. So this will become, here we use formula of d dx of log x is 1 upon x. Okay. Now differentiation of cos x is minus sine x cube minus 5 upon cos of x cube minus 5 d dx of x cube minus 5. Here we used formula of d dx of cos x is minus sin x. Okay. Now here I will write down right proper. This is minus, sorry, I will write down minus sin x. Now this will become minus tan x cube minus 5 d dx of, sorry, differentiation of x cube is 3x square and 5 is 0. Here we use trigonometric formula, that is okay, trigonometric formula is sin theta upon cos theta is tan theta. And last, rearrangement. Therefore, dy by dx will become minus 3x square tan x cube minus 5. This is your answer. Okay. Now, next one. 8th one is done. Now for 9th. Let y equal to e raised to 3 sin square x minus 2 cos square x. Differentiate with respect to x. dy by dx is d dx of e raised to 3 sin square x minus 2 cos square x. This will become e raised to 3 sin square x minus 2 cos square x d dx of 3 sin square x minus 2 cos square x. Here we used formula d dx of e raised to x is e raised to x. Now for next, e raised to 3 sin square x minus 2 cos square x into 3 will remain as it is. Differentiation of sin square x is 2 sin x d dx of sin x minus 2 cos x d dx of cos x. So here we used formula d dx of x raised to n is equal to n x raised to n minus 1. Now this will become e raised to 3 sin square x minus 2 cos square x into, this become 3 to the 6 sin x into cos x minus 2 to the 4 cos x into minus sin x. Now see, this minus minus will become plus 4 sin x into cos x. Almost that will become 10. But I will write down all the steps. 2 cos square x into this becomes 6 sin x into cos x minus minus plus 4. First I write down sin x into cos x. Now see, therefore dy by dx becomes 6 plus 4 10. So okay, I will write down first 10 sin x into cos x e raised to 3 sin square x minus 2 cos square x. Now see, I will write down this 10 as a 5 into 2 sin x into cos x into e raised to 3 sin square x minus 2 cos square x. So this becomes dy by dx equal to 5 into sin 2x into e raised to 3 sin square x minus 2 cos square x. Okay, d dx of, sorry, here we didn't use differentiation, we used trigonometric identity. 2 sin x into cos x becomes sin 2x. Okay, this is your answer. Now next, tenth one. Let y equal to cos square log of x square plus 7. Differentiate with respect to x. dy by dx. It d dx of cos square log of x square plus 7. This will become 2 cos log of x square plus 7 d dx of cos of log of x square plus 7. Okay, d dx of, here we use formula d dx of x raised to n equal to n x raised to n minus 1. Okay, now 2 cos log of x square plus 7 as it is. Differentiation of cos x is minus sin log of x square plus 7 d dx of log of x square plus 7. Here we use formula d dx of cos x is minus, that will be a minus sin x. Okay, now I will write down this like this, minus 2 sin log of x square plus 7 into cos log of x square plus 7. Differentiation of log x is 1 upon x square plus 7 d dx of x square plus 7. Here we use formula d dx of log x is 1 upon x. Okay, now see, here I will write down this like this, sin 2 log x square plus 7. This is 2 sin theta cos theta will become sin 2 theta. And this one is a x square plus 7 into differentiation of x square is 2x and the differentiation of 7 is 0. Here we used trigonometric identity. 2 sin theta into cos theta is sin 2 theta. Okay, next I will rearrange these terms. That 2x I will keep in front side, minus 2x upon x square plus 7 into sin 2 log x square plus 7. This is your final answer. Done. This is your 10th answer of 10th question. Now for 11. Let y equal to tan of cos of sin x. Again differentiate with respect to x. Dy by dx becomes d dx of tan of cos of sin x. Differentiation of tan is sec square cos of sin x into d dx of cos of sin x. d dx of tan x is sec square x. Now sec square cos of sin x. Differentiation of cos is minus sin x. d dx of sin x and d dx of cos x is minus sin x. And now sec square cos of sin x into minus sin of sin x into differentiation of sin x is cos x. This is simple one. d dx of sin x is cos x. Okay. Now rearrangement. Therefore dy by dx will become minus short small term is cos x, then sin of sin x, then sec square cos of sin x. Okay, this is your 11th answer. Now next for 12. Let y equal to sec of tan of x raised to 4 plus 4. Differentiate with respect to x. This will become dy by dx equal to d dx of sec of tan of x raised to 4 plus 4. Now differentiation of sec x is sec x into tan x. It means sec of tan of x raised to 4 plus 4 into tan of x raised to 4 plus 4 d dx of tan of x raised to 4 plus 4. Now here we use formula differentiation of d dx of sec x is sec x into tan x. Now next sec of tan of x raised to 4 plus 4 tan of x raised to 4 plus 4. Differentiation of tan is sec square x raised to 4 plus 4 into d dx of x raised to 4 plus 4. Here d dx of tan x is sec square x. We used this formula. Now next one. Okay, sec of tan of x raised to 4 plus 4 tan of x raised to 4 plus 4 into sec square x raised to 4 plus 4 into differentiation of x raised to 4 is 4x cube plus differentiation of 4 is 0. Now here we are using formula d dx of x raised to n is n x raised to n minus 1 and d dx of constant is 0 or any k. Okay. Now last is rearrangement. Therefore, dy by dx will become 4x cube into sec square x raised to 4 plus 4 into sec tan x raised to 4 plus 4 into tan of tan x raised to 4 plus 4. This is your answer. Okay. Now next, 13th one. Let y equal to e raised to log of x whole square minus log of x square. Here we have to use rules of log. Here this will become log of x whole square minus log of x square. Why? Because rule of log is what? E raised to log of m. Then here only remains m. Okay, here we use that rule. Now therefore, differentiate with respect to x. dy by dx is d dx of log of x whole square minus d dx of log of x square. So here it will become 2 log of x d dx of log x minus here it will become 1 upon x square d dx of x square. At this step we used two formulas. One is d dx of x raised to n, that is n x raised to n minus 1, and d dx of log x is 1 upon x. Okay. Now see 2 log x, again we are using that formula. Log of x is 1 upon x, it will become 1 upon x minus 1 upon x square into x, differentiation of x square is 2x. Again we are using those two formulas. Now this x will go with this x and this will become dy by dx is 2 log x upon x minus 2 by x. Okay, this is your 13th answer. Now 14. Let y equal to sine of square root of sine of root x. Differentiate with respect to x. dy by dx equal to d dx of sine of root of x. Differentiation of sine is cos of root of sine of root x. d dx of root of sine of root of x. Here we used formula d dx of sine x is cos x. Now next, cos of sine of root x. Differentiation of root x is 1 upon 2 root sine of root of x. d dx of sine of root x. This will become d dx of, okay, here we use formula of root x, that is 1 upon 2 root x. Now next, cos of root of sine of root x upon 2 root sine of root x. Differentiation of sine is cos of root x, d dx of root x. Okay. Again, we used that first formula d dx of sine x is equal to cos x. And next one is, I will write down that root x first. Sorry, I will write down as it is cos of root of sine of root x upon 2 root sine of root x into cos of roots x, and this will become 1 upon 2 root x. Here we use this formula d dx of root x equal to 1 upon 2 root x. Okay, now rearrangement. Therefore, dy by dx is cos of root x into cos of root of sine of root x. This 2 into 2 is 4, that root x into root of sine of root x. And this is your answer. Now 15th one. Let y equal to log of sec of e raised to x square. Differentiate with respect to x. Dy by dx is equal to d dx of log of sec of e raised to x square. So this will become 1 upon sec of e raised to x square into d dx of sec of e raised to x square. Okay, we used formula d dx of log x is 1 upon x. Now differential of sec x is sec x into tan x, means sec of e raised to x square into tan of e raised to x square upon sec of e raised to x square d dx of e raised to x square. Here we used formula d dx of sec x is equal to sec x into tan x. This sec x, this two are same terms, those are getting cancelled. Now tan of e raised to x square into differentiation of e raised to x square is e raised to x square d dx of x square d dx of e raised to x is e raised to x. Now tan of e raised to x square into e raised to x square into differentiation of x square is 2x, because d dx of x square is, sorry, x raised to n is n x raised to n minus 1. Therefore, dy by dx is 2x e raised to x square tan of e raised to x square. This is your answer. Now, next one. 16th one. Let y equal to log x to the base e square. So here we will use again logarithms rule, log of log x upon log of e square, which rule we are using if log of b to the base a, then we can write Now this like log of b upon log of a. We are making it as a common base. Okay. Now again this will become y equal to log of log x. This will become 2 log e. Here we are using the second rule. Log of x raised to m will become m log x. Okay, and this equation will become y equal to 1 by 2 log of log x. Here this log e becomes 1. Okay, log value of log is 1. Now differentiate this. Differentiate with respect to x. dy by dx is equal to 1 by 2 is constant, so 1 by 2 ddx of log x. This will become 1 by 2. Differentiation of this log is 1 upon log x ddx of log x. We used formula ddx of log x equal to 1 by x. Okay. Again we are using same formula 1 upon log x. This will become 1 upon x. Write down that formula. ddx of log x is 1 upon x. Last rearrangement. Therefore dy by dx is 1 upon 2x log x. This is your answer. Now next one, 17 form. Let y equal to log of again log of x raised to 2. Now differentiate with respect to x. dy by dx. I will change one bracket. This one becomes log of x square ddx. So this will become 2 log of log x raised to 1. 2 minus 1 is 1. ddx of again log of log of x. Here we used formula ddx of x raised to n is n x raised to n minus 1. That's why this 2 minus 1 becomes 1. Now next 2 log of log x. Differentiation of this first log is we are using this log 1 upon log of x. ddx of next is as it is log of log x. Formula is ddx of log x is 1 upon x. Now next 2 log of log x into 1 upon log of log x into differentiation of this log is 1 upon log x. One more log is remaining, ddx of log x. We are using this same formula, ddx of log x equal to 1 upon x. Now next 2 log of log x 1 upon log of log x into 1 upon log x. Here it will become 1 upon x. Again this formula ddx of log x is 1 upon x. Okay, so last rearrangement dy by dx will become 2 log of log of log x upon, I will write down this x first, then log x, and then log of log x. Okay, this is your answer. Now last question for second question. Let y equal to sine square x square minus cos square x square differentiate with respect to x. This become dy by dx equal to p dx of sine square x square minus d dx of cos square x square. First differentiation of this square, 2 sine x square into d dx of sine x square minus 2 cos x square d dx of cos x square. Here we used formula d dx of x raised to n, that is n x raised to n minus 1. Now 2 sine x square into differentiation of sine x is cos x square d dx of x square minus 2 cos x square, differentiation of cos is minus sine x square d dx of x square. Okay, here we used formula d dx of sine x is cos x and differentiation of d dx of cos x is minus sin x. Okay, so this becomes 2 sine x square into cos x square into differentiation of x square is 2x minus this minus minus become plus 2 cos x square into sine x square into 2x. Again we use formula, this formula d dx of x raised to n is n x raised to n minus 1. Now see, this is 2 into 2 4x sine x square into cos x square, same 2 into 2 plus 4x, I will write down sine first, sine x square into cos x square, 4 plus 4 becomes 8, this is 8x sine x square into cos x square, but I will write down this like this, 4x in bracket 2 times sine x square into cos x square, this is 2 sine theta cos theta, that's why it becomes 4x into sine 2x square. Here we used formula 2 sine theta into cos theta is sine 2 theta, therefore dy by dx becomes that. Here second question ends.